Nick Schrock is the co-creator of GraphQL, and he works at Facebook. Nick, welcome to Software Engineering Daily.
Hey, thanks for having me.
This conversation will focus on GraphQL, but we should start with a conversation about the paradigms that GraphQL is trying to replace. In today's world, there are two dominant architectural styles for client-server interaction: REST and ad hoc endpoints. Let's start with REST, or representational state transfer. How does REST manage client-server interaction?
So I'll first say that there's often a little controversy of what REST is. People are very ideological about this, and so I always qualify this as that I'm talking about systems that self-identify as REST. This is a very nice sidestep that allows me to avoid these issues. But that is what matters in the modern context. So what REST typically is a way of doing client-server protocols such that you are generally interacting with a single entity type, whether you're accessing one or many objects per HTTP request. And then in order to link to items that are connected to those entities, typically they are communicated via resource URLs. This is very convenient when navigating these APIs via a web browser because you can click around and get everything. But in our opinion, for production applications that go over networks, that is actually pretty undesirable.
And why do REST systems often require multiple round trips between the client and server?
Well, it's just the nature of the beast, I guess. Because of the nature of the protocol I just described, in order to successfully navigate an object graph, you have to do multiple round trips. So, for example, if you access, we use this example of the Star Wars API because everyone knows and loves Star Wars. You might be able to access a character in one round trip request, and you ask, they have a list of planets they're associated with or something. That's typically just an array of URLs. And so in order to get information about the planets they visited, say, you have to go through all those URLs and make requests, subsequent requests in order to do that.
And in what ways does this multiple round trip approach particularly impact mobile applications in variable network conditions?
Well, it's just because round trips are the high order bit of poor performance. If you're walking around in India, every round trip, your ping to a server might be on the order of hundreds of milliseconds, or basically a second.
Yeah,
and that ends up being unbelievably awful, to use a technical term.
So REST is one type of dominant style for client-server interaction. And there's also ad hoc endpoints. What is an ad hoc endpoint?
So ad hoc endpoint is simply a arbitrary piece of code that often takes parameters that you access via HTTP request, and it returns whatever data it wants. So it's very flexible, but very opaque in terms of tooling, and often leads to very inconsistent code bases. And in reality, I really don't separate REST systems and ad hoc endpoints that much in my mind, because any production system that I've ever encountered ends up being a continuum between REST endpoints and ad hoc endpoints. So that usually ends up being that the interactions that don't matter that much or that aren't used that much are using the more traditional REST-style endpoints because the performance doesn't matter as much. But for the critical interactions in the app, people just have to build completely custom code because they want to navigate between multiple entity types in one round trip.
And before GraphQL, Facebook had to deal with these problems that are associated with REST and ad hoc endpoints in much more violent ways, as I understand. How did Facebook deal with these problems that you've outlined?
So there's essentially three stages to the history here. Stage one was our first native applications. especially on iOS. And our first iOS app was pretty much written by one person named Joe Hewitt, and he did it really on his own, independently, very quickly, and he simply just built custom endpoints for every single interaction in the app. So that was stage one. Stage two is we went to an HTML5 hybrid approach, in which case that was not an issue. Our endpoints simply served HTML5. Once we were rebuilding our apps in native in 2011, it's actually an interesting story. We kind of had a mismatch of custom build endpoints, but then the team that originally was building the iOS app wasn't actually too experienced within the Facebook organization, and they thought they could build the entire site on FQL, which is our query language that our external platform defines. But it turns out that the data we expose via our externally facing platform is pretty dramatically different from the data that we need internally. And we also found that the API for FQL for building really complex object graphs really was not going to hold up very effectively.
Did you initially think that FQL, or did Facebook initially think that FQL, like what you said was the externally facing query language, did you initially think that it would satisfy the internal development needs of Facebook as well?
Some people did. It was there was a project to build the site on platform and ergo FQL, and that project was not successful and was eliminated.
Where did the rubber meet the road on that one? Like what went wrong?
Well, the thing is that there's actually a structural business reason why that won't ever really work. And that is the needs of our external developers are just dramatically different from the needs of our internal developers. Mm-hmm. No one is going through the work of rebuilding Facebook from scratch using our external APIs. They're doing generally two things. One is they're sucking down our data so they can connect, use our social graph to augment their application. I'll say three things. They're also doing authentication to expedite sign up, and they also are injecting stories and information into our system in order to juice distribution. So it was kind of, in my opinion, fairly misguided to think that you would want to use this for both platforms.
Got it. So with that said, what is GraphQL?
So it is a hierarchical query language, hierarchically strong type query language that product developers use to access their data. Would be the most tight definition.
And how does GraphQL solve the problems that we've outlined previously with the RESTful problems or the ad hoc endpoint problems, just these classical client-server interaction problems?
Right. So it is designed, first of all, with the product developer in mind. So we began with the API experience of that product developer and worked backwards to technology. It's kind of like building a technology product for consumers. You start with the consumer experience and work backwards toward technology. So I think that's a critical piece. Directly relating to the issues you were talking about before, it was designed to do a single round trip in mind, meaning that you have a view, it has a specific hierarchy of data it needs, you declaratively say that hierarchy of data, and then you issue that one request to the server. Furthermore, there's a strongly typed, the system that it operates on is strongly typed, so you can access the type system via tools. So you can build things like type aheads, you can do code generation very easily, and any other number of interactions. This is another way we think it's superior to, or is an improvement over ad hoc endpoints. Those ad hoc endpoints are generally very tool poor. They don't have a type system typically, and often they give inconsistent results between the different custom endpoints, even though they're accessing the same data. So we really think it's a step forward in client-server interaction.
Can you give an example of a query and how an application would consume that query?
Sure. So I would say the canonical example is the news feed. So our news feed, which is one of the most complicated products on the planet, is you access the data via a single GraphQL query. And that GraphQL query accesses every single story type. Within every story, accesses the number of likers, accesses the comments. We now have nested comments. We have attachments within comments. We have likes of comments. We have photos embedded in comments. We have our story structures are incredibly complicated. Stories can have sub-stories. Stories can have multiple attachments. Those attachments can have sub-attachments. And then we have all the feed units, which really don't fit the standard template, like our app install units or some of our units the growth team comes up with. And so it's just a wildly diverse product where the number of nesting levels is incredibly deep, and we do that in all one round trip.
Is GraphQL an ORM?
Absolutely not. ORMs are maybe my least favorite abstraction, and I think is a plague foisted upon software development in general. And someone famously called the Vietnam of computer programming, and I have to say I agree.
The Vietnam of computer programming?
Correct. You can't get in, can't get out.
Okay. I see. So,
as in the Vietnam War.
Yes, no, I understand. Not Vietnam
Okay.
in general. Not
right.
Vietnam is entirely made of quicksand. So you've said that the goal of GraphQL is to start with this view layer, or start with the developer experience, and work backwards. Can you describe this process in more detail and how you designed GraphQL with that in mind?
Sure. So product developers and designers, when they're thinking about data, think about data in terms of hierarchy and graphs. And by all, I mean the lion's share and in general. And that's because the data they are dealing with is typically hierarchical, and then the views they construct are hierarchical, right? Any UI developer constructs hierarchy of views. Each one of those views has to access certain amounts of data, and that data has a similar relationship to the viewer relationship. So essentially, this allows a product designer to think about two structures that are very closely interrelated with each other, rather than a view structure, and then you need to think about the data on a completely different axis.
Right, and so for listeners who are still not sure where exactly GraphQL fits in, they might be thinking like, oh, it sounds like SQL. But GraphQL exists on a different layer than SQL, as I understand. Well, depending on how you're accessing the actual data from the database. But could you clarify more where exactly in the stack GraphQL sits?
Sure. SQL is a language that sits atop a storage engine. So the way that you structure things typically is in a SQL world is that you query for data out of a SQL database, pull that data into some sort of middle tier, and then you have a bunch of code that runs on top of it to reshuffle it, to integrate it with other services, and then you return it back to the client. GraphQL is different. GraphQL is a layer on top of your business logic. So it's a structured, programmatic way to access your application code. Every single field in the GraphQL query is backed by arbitrary code. It is not backed by a specific field in the storage engine. This is interesting because fields in GraphQL don't even necessarily have to have direct representation in storage. They can be synthesized fields that are created in software. So, for example, in Facebook, whenever you like something on Facebook, there's you, some person, and 1,300 other people liked this. Now, That constructing that sentence is a shockingly complicated process because there's many forms of them, and then we have to internationalize it. So that has to go through a layer of software. However, from the standpoint of a client, you simply specify like sentence, and then it just spits that back to you. It would be completely unrealistic to actually store that sentence because of the internationalization issues and whatnot.
And how does a developer spin up a GraphQL server? I'd like to describe the end-to-end process of, what the experience is from having a GraphQL query hitting the server and being processed in entirety and returned.
I see. So let's imagine you're running a node server, and let's imagine that you were wrapping an existing REST endpoint or a sequence of REST endpoints. This is actually a very effective way for kind of incrementally introducing the idea of GraphQL to your existing systems. So what you'd do is you'd go and npm install. I think the best way would be the Express plugin. And Express is an HTTP library and server for JS. And then you would also have our GraphQL reference implementation alongside that. So what that piece of software gives you is an HTTP endpoint that accepts a string, parses that string, validates that it is valid within our type system, and then it executes the query using our component called the executor. Now, where you come in as the application developer who's adapting this is that you define a sequence of type definitions that maps to your data model. And then for every field in each of those type definitions, you map that field to a piece of arbitrary code. And that's where the glue happens. So you build these type definitions that, in a more concise way to put it, maps the GraphQL type domain to your internal applications type domain. And that's how you would get started in today's world.
Okay, so GraphQL was created around the time that you were building your native mobile apps. And I know you described steps 1 and 2 of the 23-step process, but this is probably going to hint at some of the other steps. So GraphQL, I think, originally was designed to be this data fetching API that would describe all of Facebook, and whatever initial effort that was evolved into what became GraphQL. So could you describe more about that process?
The process of creating GraphQL?
The process of how this project to evolve a data fetching API, like how it went from just this more abstract process into the well-defined vision of GraphQL.
So the story of this is honestly that one of my friends was working on the iOS team. Bo Hartshorn was his name. And I had been responsible or involved in building a lot of Facebook's internal data abstractions. And he realized very quickly that FQL was not going to be up to the task of servicing the iOS application. So I was on a different project, and he essentially stopped by my desk once a week and told me how screwed we were, and had to do that several times before it sunk into my head that we were screwed. And then effectively, Lee, my other primary contributors, Lee and Dan, were working on their own projects that were in this realm. So Lee was working on a well-structured feed API. Dan was working on dramatically improving the internal abstractions of feed. And then I kind of submitted the first proposal of the system in the form of a chunk of code that we call an RFC, request for comments. And then our efforts cohered and we kind of marched forward. And then, that was an incredibly focused, incredibly a project done under severe time constraints. And I think we did a reasonable job of getting a system that was close to the mark, given the time constraints and pressure involved. But the system's evolved in the past 3 years. So really the open source opportunity was a chance for us to step back and reevaluate what we've built. We've learned a ton of lessons over the past 3 years. And we were able to correct a ton of mistakes and really design it from the standpoint that GraphQL would be used a ton to model a ton of behavior in our client software. Originally, we just thought of GraphQL as an API that spits back JSON. But what it really became was the interface for our product developers, not only to the server, but to a ton of client software, including persistence and other features. So that's kind of the evolution of how this happened.
Sure, and we'll talk a little bit more about the open source process a little bit further in the interview, but I'd like to talk about Relay. What is Relay?
So Relay is a client-side API used to build UIs. And simply put, it stitches together React and GraphQL such that you can co-locate your data requirements with your view specification. And really, and in a declarative fashion. And it's a really exciting API, and it is the best product-facing API I've actually ever seen.
That's a strong statement. So for listeners who are interested, there's a Relay playground on the Relay GitHub page, and I'll put that in the show notes. It has some great interactive modules. Nick, could you give an example of how to use Relay, and could you illustrate what role it plays in application development?
Yeah, I guess I find it hard to think of a particular example because it can be used to build effectively any sort of client application, right? So I guess I'll ground this in an example of feed again. So our news feed has dozens of story types. And the model without Relay, which is what we use on the iOS and Android apps, is the following. If you want to change a story type, you have to deal with two different files, right? One is the view, and it probably ends up being like 12 files because it's a complicated thing. And the other thing is a GraphQL query, and they are separated, right? Kind of classic view model separation. So I go into a story, and I muck around with some things, and then I have to muck around with the GraphQL query in parallel to that. Now, that seems reasonable until you actually scale and grow an application, and the queries end up becoming separated from the view hierarchies because they're a centralized resource that everyone has to touch. And then they end up growing a lot, and it's very difficult to actually rip out things that are unused because you end up flowing all these objects throughout an entire code base. And you don't want to be the one to make the mistake of ripping out a query, a field that is unused in a particular interaction. And it just generally is much more difficult to manage. So by co-locating the view and the data, you essentially can kind of keep your head in the one component rather than having to muck with the centralized information that everyone has to touch.
So if a developer wants to work with Relay, does that necessitate using GraphQL?
Currently, yes.
Okay. Is there a looser coupling on the roadmap, or?
I think this is one of the times where the roadmap will be influenced by the reaction within the open source community and how people adopt it. So I fully expect developers out in the community to develop polyfills for the system, and I'm actually curious to see what people will come up with, because developing a GraphQL server is, especially now, given how new the ecosystem is, it's a big task. As time develops, we want to make GraphQL more and more plug and play, but that is a evolving process, and we don't know when we're going to get to a spot where you can get a GraphQL server up and running in a couple minutes.
It's like a very nuanced advantage of having your code open sourced.
Yeah, it is. So I would say there's a trade-off with this open source paradigm, especially, and by open source I also mean kind of erring on the side of early releases that are rough around the edges. So for the early adopters, it can be a little rough to deal with, and it doesn't feel as industrial strength and locked together from, say, like a bunch of Apple or Microsoft APIs. However, on the flip side, for those early adopters, you can really influence the direction of the product, and we can really vibe off their ideas very quickly in order to evolve the system in a way that people want. So I think there are trade-offs involved, but we've really been well served by this open approach, and I think the community has as well.
With Relay, the queries live next to the views that rely on those queries. This comes back to the idea of starting with the UI and working backwards. How does the experience of developing in Relay compare to developing in a framework where the queries are not so co-located with the view?
Yeah, so this gets a lot of pushback because traditionally people are very concerned about model-view separation, and this was taken as given that this is the correct way of doing things. And a lot of people say, okay, you're coupling the models and the views, and that's bad. Well, our position is the following, that we are acknowledging a coupling that already exists in fact. It just is a statement of fact that if you add a piece of data to a view, it is coupled by a change and an additional piece of data in the model. That is a fact of the universe that you cannot avoid. So we are acknowledging a coupling that already exists. But we don't eliminate the separation of concerns. By having these two couplings, but declared in a declarative fashion, that's a bit of a tautology, you can actually have centralized components that can analyze and execute these things independently. So I often believe that these dogmas and paradigms are dictated by previous nightmares in development. And one previous nightmare was templating systems that serially executed and then alternated between building markup and executing against a database or some other data backend. That was terrible coupling because it coupled it in terms of the execution style. There was no way that you could actually make it so you could execute database queries and do computationally intensive markup generation in parallel or orchestrate them. But if you have the UI and the data in a declarative format where some sort of centralized authority is able to make global optimizations against them, you're able to have the best of both worlds. So we do have a separation of concerns. In our case, the separation of concerns is between execution and the declarative specification of the API.
Yeah, I actually really admire Facebook's willingness to just have no sacred cows when it comes to redefining development or how Facebook wants to do development. You see this with Relay, you see it with Flux, just kind of abolishing model view controller. You see it in React with the JSX markup, and it's really endearing, to be honest. Like, from the standpoint of a developer, like just a developer even outside of Facebook, I'm like, hell yeah! Like, down with the software hegemony.
Yeah, certainly not all developers will use the term endearing, but I appreciate that you think so.
Yeah, I mean, it's kind of rebellious in some way. It's like highly structured rebellion. Can you describe a mutation in Relay?
Sure. So Relay's mutation model is certainly based off the Flux model in that we have centralized mutation logic that mutations need to be functions. So a typical other approach to the mutations is to have, like, say, triggers. So in other systems, you would have an object, some mutable object, and you'd set some properties on it, and then you save. And that's what you do. And then in order to manage side effects, you have triggers that say, on save, okay, I'm going to do such and such of this. The problem is that this is actually at the wrong level of granularity because there are multiple contexts in which you would actually mutate an object. So then what you have to do, let's say you mutate your user in 4 different contexts, and you need to manage some side effects, but only in a certain UI flow do you want to do some specific side effect. So you have to either have some global state that you have to kind of magically set, or you have to somehow encode that use case, that specific use case, in the set of changes in the object, and that's very flaky in order to manage these side effects. We kind of just say, listen, that's the wrong abstraction. That's at the wrong abstraction layer. You just have to have explicit mutations, and then they just execute code. And in order to make it so you can kind of share code between them, you have to just structure your code such as it decomposes well. So that's the same philosophy that Relay uses, and that's the same philosophy that GraphQL and Mutations use, and that's why the systems merge together so well.
Right. You mentioned Flux architecture. How do Relay and GraphQL fit into the Flux architecture?
So, as a confession to make here, I am mostly a GraphQL guy. So, I am really not an expert in Relay or React, and certainly not Flux. So, I'm speaking from some ignorance here, if that makes sense.
That's
so
fine.
question,
I'm asking from even more ignorance. So there's some nice arbitrage we can find there.
Right. So the question was, how does Relay and GraphQL fit into Flux?
Yes.
So as my understanding goes, and hopefully I don't enrage any of my colleagues, Relay effectively replaces Flux, or at a minimum is built on top of it and makes Flux dramatically simpler. Because they are the same philosophy in terms of centralized mutations, 1 mutation per functions, and so on and so forth. So they are highly compatible philosophies and maybe systems.
Okay.
But I would ask someone else about that specifically.
Sure.
Plus, from an external person, there's is my last count, approximately 345 Flux implementations. So it's often difficult to tell what Flux is and isn't.
Yeah, seriously. So, I mean, what are the common? I mean, okay. I guess following up your your admitting to not really knowing about Flux. Why are there so many implementations? Is it just because? Does that just speak to the looseness of the Flux definition? Because I've literally asked every person I've interviewed on this topic, what is Flux? And I kind of get different answers each time.
Yeah, and I think this is part of the goal of Relay, is to effectively provide real code that is an implementation of Flux that everyone likes, therefore somewhat ending the debate and effectively supplanting it. And Flux was more of an idea rather than a formalized piece of code, which is why it kind of launched 1,000 ships, as you were, in terms of different NPM modules. And clever names for the project too.
So, what are you spending your time on the GraphQL project? It sounds like you're not. Do you spend much time interfacing with the React team, or are you just heads down working on specifically GraphQL stuff?
No, we absolutely are fully integrated with the Relay team, and then by extension the React team. So I can literally turn around and whisper, and the Relay team can hear me. They sit right next to us. We work with them, in lockstep, and so a lot of our work is supporting them and ensuring that they're successful. In terms of what the GraphQL team is working on, our next major focus is actually backporting the changes we made in the open source version of GraphQL to Facebook's version of GraphQL. So the version that we open source is actually relatively different in terms of some syntax and the way the type system works. And we really want to bring those changes back into Facebook's internal version such that we can really sync and all be building on the same infrastructure. So that's critically important. And
interesting. So could you talk about that open source process a little bit more? At what point did you open source GraphQL? Or you just open sourced part of it? Or I guess tell me the story behind that.
Yeah, so the story effectively starts in late in winter of last year or beginning of this year when effectively I sat down and begged Lee to work on this. I called it my Byronic fantasy. His last name is Byron. And, the thing that really spurned it was that the Relay team, in the spirit of React, wanted to open source their work. But if you can't open source GraphQL, you can't really open source Relay, or it's not nearly as effective. So that was really the impetus to do it. And I would say the other impetus to do it that really excited the rest of the team was the React.js conference at Facebook in, I think it was February. And we talked about GraphQL for about 10 or 15 minutes in the form of a presentation and a slide deck. And I thought this would kind of just pass people by and be like, oh, I don't, this is a very non-specific thing and it looks good in the slide, but I don't get it. But I mean, we were shocked at how big a deal people thought this was. And then people actually started to try to implement the system based on like 3 slides. And so we stepped back and we're like, this is ridiculous. We should actually really support these people. We should support Relay, and we should really commit to this. And then because, one of the things that happens at Facebook, by the way, is that sometimes we don't realize that what we built was actually good, because it's like the Louis C.K. bit. I don't know if you're familiar with Louis C.K.
Yeah, I know who he is.
Comic. So he has this hilarious bit where he's describing how everyone gets mad in planes all the time, and how they're just accustomed to the fact that they're going 600 miles an hour in a chair, and it's amazing. And if you told someone 100 years ago this is how things worked, they'd be absolutely blown out of their mind. And he describes how someone was using Wi-Fi on a plane for the first time, and within about 10 minutes, they were complaining wildly at how slow it is. And he's like, you didn't even know that existed 10 minutes ago. Can you be thankful for a little bit? So, people get accustomed to technologies within the company. So you kind of get a lot of negative feedback after people are accustomed to the change. And I think this is a case where kind of, bringing it out into the open, a technology that people were used to internally, to a new audience that had never seen it, was really invigorating, because it was kind of a reminder that what we built was actually good. And so I think kind of all those reasons. And then it was an opportunity also to re-inject some life into the language. Internally, it felt a little stagnant. And this is a really great opportunity to rethink a lot of our design decisions and provide a new focus for it.
Were there any dogmas that had developed, or just things that you were starting to overlook that got exposed immediately once you released it to the open source community?
Let me think about that. So there's definitely been positive pieces of fairly, on the scale of things, relatively minor feedback. I think it's more of an aspect of what we thought was really important versus not important. So there's a lot of features that we thought were going to be mission critical to the app that are much more relevant within Facebook than outside of Facebook. And then there's kind of more nice to have features that are just really important to the open source community. And in particular, I think the thing that we need to up on our priority list is making the system more lightweight and typeless, at least when you're first developing your application. We would love to be able to have GraphQL kind of have a parse-like property where you can just kind of start throwing data at it and having it dynamically build up the schema when you're first just exploring an app. Because you don't really know what your type system should be until you start playing with the application. So why should you make someone formalize a type system? And only once you understand your requirements better and you need to build more UIs and more views of that data, then you can start to formalize your type system. So I think that is super useful to the open source community, who often work on applications with smaller teams and applications which are much more inchoate, to use a fancy word, or just newly forming, where the type systems just aren't necessarily set in stone.
Do you feel like at Facebook, dynamic typing is pretty much avoided?
No. So our philosophy in general is what we call gradual typing. So this is embodied in both Hack, which is our PHP offshoot, as well as Flow, which is our typing system on JS. So the idea of gradual typing is that you can write completely dynamic code if you want, and then use type annotations to gradually type your code, one function, one argument, one class at a time. And then you use type inference extensively in order to detect derivative errors. So effectively what we want to do is apply that same gradual typing philosophy to GraphQL, where you can do it in a completely, and I'm kind of spitballing here, and the rest of my team might be mad at me for overcommitting in public, but kind of ideally we'd want to be able to kind of allow highly dynamic or at least much more lighter weight types at the beginning, and then be able to gradually type it to be more strict as the application requirements become more clear.
Interesting. So this week is focused on React, but it's kind of bled into this broader conversation about Facebook developer tools. And I feel like I hear a lot about developing on the Android platform, developing on the iOS platform, but I don't hear much about developing on the Facebook platform, and I'm not sure why that is, because I'm looking at all these tools and like these things. I mean, I guess it's probably more due to the fact that Facebook seems like it's just releasing these loosely coupled tools, and Ben Alpert talked about this. He said this was very, very intentional, that these things do not cohere to form some sort of framework that forces developers to do one particular thing. But I'm curious, where is this going? Like, what is is there an end game for the people that are developing these Facebook tools? Is there a vision that you see that you would like to impart to the rest of the developer world?
Yeah, there definitely is. So I would slightly rephrase what Ben was talking about, in that, yes, all of these projects are loosely coupled. All of them, in and of themselves, are extremely useful technologies and can work alongside other technologies. But they do all philosophically cohere together and build on each other. So I like to say that the whole is greater than the sum of their parts. Now, what we don't, I think eventually we could cohere it into a platform that has a name and that's more formalized, but we aren't quite there yet. What we're really looking to do is form a coherent platform that evolves organically, meaning that other people contribute ideas and we see how these different technologies compose together to form a more coherent platform. So what we're calling this kind of this style of platform is it's horizontal and opinionated, meaning that there's React is an opinionated platform. It has values, right? It doesn't try to be all things to all people. It has very specific principles. So it favors functional programming, immutable data structures, co-locating markup with code, declarative APIs, and this is a really powerful. This is one of the reasons I think why it's so popular, because in order to adopt it, you kind of have to join the party. You can't just do it. You have to change your behavior and the way you think about things, and this applies to all our different technologies. By horizontal, I'm thinking specifically of React Native and GraphQL. So React Native does not claim to be a full stack. It is a fairly thin, in the scheme of things, layer that provides a JS runtime and software over that enables you to write React applications over that JS runtime that can target any native platform. Currently, obviously, the most important ones are iOS and Android because that's where the users are. So, you can really start to see these layers of software form into a coherent platform. So it's getting to the point where, within Imagine a world where you have GraphQL as a service and you can spin up and start throwing data at a GraphQL server within minutes. And then you can also, because the tools are good, build UIs very quickly. So you can imagine this kind of mother of all demos scenario where you go on stage, you build a to-do MVC app in a mobile website. And then you're like, wow, that was fast. We have data going back between a client and server. And then you're like, wait, I can change these views very subtly, and boom, you have an iOS app. And you have an iOS app without any of this BS of Xcode, without provisioning profiles, and all the nightmarish aspects of developing an iOS. And then you do, I'm going to change a few more things, develop an Android app. Boom. And one person in 15 minutes has kind of done hello world on all three platforms simultaneously. You've used the native capabilities and are sharing the majority of the code in a single code base. And this type of scenario, if that's not a platform, I don't know what you call a platform.
So then at that point, wouldn't Facebook want to just make its own hardware?
You're never supposed to say never, but no, that's not what we're about. I'm not sure what the advantage would be at that point of making your own hardware.
Well, presumably, like Android and iOS have all this cruft, and I think people are kind of tired of the duopoly, right? Mm-hmm.
I mean, I would say that question is a bit among my pay grade. If you could snag an interview with Mark, you might be able to get a more coherent vision of that. So I don't think it's my place to say anything about that.
Maybe this is your path to getting a raise.
Yeah. But I don't want to outkick my coverage here.
Yeah, so. Fair enough. Fair enough. So no GraphQL operating system. We won't even talk about that.
Yeah, I don't think that's going to happen.
So I saw the spec for GraphQL, and it's really long. Who wrote that spec?
So that was Lee Byron, myself, and Dan Schaefer. And let me say, I have a newfound respect for those who write specifications. And if I live out my days without writing another one, I will be perfectly fine with that.
Yeah, like I'm looking at this thing right now, and it's just like super, super long and super, God, I don't know what the word is, but how do you make a specification? Is there some set of rules or standards that you have to follow?
So not really. So one, Lee codes like a madman. So he actually built a custom tool for building the specification, essentially a markdown variant. And that is open source, I believe. I think it's called spec-md. So that helped. And then we effectively just kind of copied the style and the idioms of the JavaScript spec, which, by the way, is approximately 10 times as long as the GraphQL spec. The other thing I'm going to say about the specification is that even though it's long and it's complicated, we really only hope and anticipate that a very limited set of humans in the world who will actually have to fully understand and absorb the entire specification. Now, if academics or anyone who's interested in it for funsies wants to engage, that's fine. But in order for GraphQL to be successful, that spec does not have to be widely consumed, because one of the principles of GraphQL is centralizing complexity, meaning that you can't get rid of complexity, but you want to centralize it so only a few people have to manage it. And then you present an API to the rest of the developers where they just kind of can understand these concepts intuitively through tools and whatnot. So, I want to make sure to be clear on that. If you show an average developer or just a product developer doesn't think about things like a core GraphQL spec too frequently, if you show them the graphical tool, which we have open sourced, the understanding of the power of the system is instantaneous, and you can be productive very quickly. I, in fact, think it's straightforward enough that a lot of people who are only mildly technical, say a program manager who hasn't coded anything in 10 years, or a designer who can effectively only interact with CSS and markup, in general, they can actually interact with this data very quickly. So, yes, the spec is complicated, but it's only meant to be read by a limited audience. In the same way that the JavaScript spec only is really read by browser implementers.
Right. Interesting. So we talked a little bit about this, but what is the open source strategy at Facebook? Like, what is the policy, and what are the intentions? What are the goals of open sourcing software?
That's a fantastic question, and it's pretty non-obvious. But I'll make a few points. One is there's simply an ideological belief within the company that it's the right thing to do. So individual employees clamor for this, and it feels correct. Second of all, I think it actually ups our level of execution, right? So when you have to market something, when it has to be open to the entire world and people can make fun of your implementations or whatnot, it forces you to up your game. And I think that's actually served the company really well. Third, the open source contributions back into our software are considerable. And that in turn helps the company, right? So the contributions back to React have been really meaningful. And that transitions into another point in that it helps with recruiting. In terms of before we open source things, I think the world kind of thought of Facebook as a bunch of like script kiddie clowns who were moving fast and breaking things and didn't know what they were talking about. Now we had confidence that we actually did know what we were talking about. The group, the engineers that I work with are, some of the most talented engineers I've ever worked with. But no one knew that, right? And by open sourcing the stuff and publicizing our internal abstractions, it's like, wow, actually, there's some really interesting work going on here, and I want to be a part of that. And then kind of all of those benefits are predicated on the structural nature of the technology industry, in that the vast majority of relationships in the technology industry are not zero-sum, meaning that if we make someone else better, we don't make ourselves worse. So if we open source something like React, and companies like Stripe or Square or Uber or whomever else makes better software, actually, we kind of believe that's better for us too, right? If the entire ecosystem works better, it's better for us because more people will engage with software, everything's faster, you can go between apps, so more engagement with software across the industry is good for Facebook. So it's because of these non-zero-sum relationships that I think this all really works. If it turned out... Oh, go ahead.
I think that non-zero-sum situation is actually super important for anybody that's looking to advance as a software engineer or just as somebody in the kind of Silicon Valley ecosystem. I used to play poker a lot, like kind of semi-professionally, and the thing about the poker ecosystem is that a lot of the behavior is zero-sum, just because you're playing this game that is inherently zero-sum, and so the behaviors within the game bleed out into the way that people treat each other. Yep. And it makes for this very unsavory environment. And when I transitioned from playing poker to writing software, it was this very interesting, gradual, and sometimes very difficult transformation, because I had to realize people actually want to help each other because it's like 1 + 1 = 3. Like, if you're not trying to help somebody else, you're screwing yourself.
Yeah.
So yeah, I don't know, it's very idealistic, but it's sensibly idealistic.
Now, I think it's also important to note that there are relationships in technology which don't have this character. When Google released Google Plus, that was competition. We would not go out of our way to help them, to put it mildly.
But they shot themselves in the foot. Like that was a kind of that's almost like a lesson in don't go for the zero-sum situation.
I would say that's true. And how glorious was that to behold?
it was really glorious.
But, I think Peter Peter Thiel's most recent book, and I'm blocking on the name of it.
0 to 1.
Yeah, 0 to 1 really speaks about this. Is that, listen, don't go for these direct competitive relationships, because even if you win, you often don't have a very profitable business or a very successful business. So, instead of doing that, don't do that. Do something else.
Right. Don't build the social network for cats. Don't build the 18th restaurant in Palo Alto. So you've been at Facebook for more than 6 years, and I'm curious how the developer culture has changed, because over those 6 years, from 2009 to 2015, I think Facebook has undergone this. I don't know how it looked from the inside looking out, but from the outside looking in, Facebook has gone from being this organization where you're building the obvious core Facebook platform, but since then you've also done all these other things like gone to drones and stuff like open source JavaScript module component libraries, and it seems like Facebook has really matured as an organization. So I'm wondering if it looked the same way on the inside as it did from the outside.
Absolutely not. So when I joined Facebook 6.5 years ago, I encountered an extremely uneven engineering organization from my perspective. So a lot of the engineering practices, frankly, I was kind of appalled with. The code base was in very rough shape. But there were other aspects of the organization that were just world-class, the best I had ever seen. So what I was completely blown away by was the velocity and aggressiveness that the organization operated with. So I came from a world where you'd ship client software or deploy software very conservatively. At Facebook, if you checked in a piece of code, it was going out to the world on Tuesday. And we were pushing new code live to the site every day, sometimes multiple times a day. In addition, we didn't do branches, and we aggressively experimented. So the code base is like littered with, if you check this system. So we had a system called Gatekeeper, which allows you to dynamically target different features to different audiences. So we do stuff like launch features to just New Zealand, or to just certain demographics to see what the effects are, and then we measure them, and we have highly sophisticated data scientists that analyze that stuff. I had never seen anything like that in my entire life. It was amazing. So, looking back on it, I think a lot of the reason was that at that time in the company's history, we were growing. The site was less important to the world, so you could kind of be a little more sloppy and get away with it, and it wouldn't be the worst thing in the world. I mean, we're still not building nuclear reactors, but it's a much more critical piece of communications infrastructure, and people are building their businesses on it. So, in 2015, it needs to be much more industrial strength than it needed to be in 2009. And that focus, we have these corporate mantras, and one of them is focus on impact. And that sounds kind of anodyne and cheesy, but if you actually really internalize it and you actually operate on that philosophy, it's actually a very difficult thing to do, because you have to ruthlessly prioritize. You have to decide that, objective X is the most important thing, even though all of your engineering trades, craftsmanship tells you that you need to fix this other thing for your soul not to be hurt. And so I really think that singular value is what's driven a lot of this. So we've needed to scale up our organization, right? We've needed to, we have tons more engineers. Therefore, in order for them to be effective, you need to improve your software abstractions. And, and it's also kind of combined with this, ruthless pragmatism too, where everything's very goal-based. It's not as much, we need to mimic this academic paper, or, we need to do exactly the best practices in the community. It's instead, with awareness of best practices and good ideas that other people have come up with, what's the best way to accomplish our goal? right? So our goal is to build the best, with like Relay or React, is to build the best front-end facing API on the planet. That's what we want to do. We will steal and copy and use whatever best practices we need in order to accomplish that, and we're going to ignore the ones that we don't think accomplish that. So I think it's this kind of core set of values which is like led us along this path.
It's great. Well, Nicholas Schrock, thanks for coming on Software Engineering Daily. It's been a real pleasure talking to you.
Thanks, man.